All right, hi guys. We are starting the next unit here, which is going to kind of be half and half, two different things. We're going to start with some distance and midpoint formula, which might be a little bit of review for you. It might be new. Either way, that's fine. And then we're going to do some stuff with circles. We just talked about a lot of parabolas, so we're going to also do some work with circles and their graphs. But in order to do the stuff with circles, we need to know these distance and midpoint formulas. Okay, so first thing we're going to do is kind of review something that should be really familiar to you, and that is the Pythagorean theorem. We learned this in middle school. We talk about a little bit in Algebra 1. But just to remind you, a Pythagorean theorem, or the Pythagorean theorem, is when you have a right triangle. And if you remember, a right triangle means it has a right angle. We mark it with a little square. And then we have these two sides, A and B, those are the legs. And then the longest side, or the side that's across from the right angle, is the hypotenuse. That's what we call C. Pythagorean theorem says that the sum of the squares of the legs, so a squared plus b squared, is equal to the square of the hypotenuse. So that a squared plus b squared equals c squared. You guys probably remember that, right? So with the Pythagorean theorem, we can actually use that to find the distance between 2 points. For example, let's take these 2 points here, -4, 4, and 3, -2. First thing I'm going to do is I'm going to kind of sketch a graph over here just to kind of get a visual of what's happening. So if I've got -4, 4, that's somewhere around here, right? So there's -4, 4. And then our other point, 3, -2, is maybe somewhere around there. Right? If I get my labels on there, that makes it accurate. Okay, and then basically I want the distance between those 2 points. So that distance would be a straight line from one point to the other. So that length there, that's our distance, right? From one point to the other. Now, to find that distance with the Pythagorean theorem, what we can do is we can actually look at, well, let's make this into a right triangle. If I kind of dot in the vertical and horizontal parts there, that's a right triangle, right? So now I can think about, well, if I can find those two sides of that triangle, then that means I can find the distance, or the d, the c squared, right? So basically, if I look at, I kind of color code these, this one over here, that side, well, that would be how much I drop down from the first point. So I'm going to look at the y values, right? So the y values go from 4 at this top point to -2 down here, right? Because right here is 4, and right here is -2. So that distance there would be 6, right? I go down 4 and then 2 more, so that's a distance of 6. Now, if I look at the horizontal distance over here, right? Oh, that's not a very good bracket. I'll try that one more time. Hard to draw that way. Right? If I look at that, now I'm looking at the x values, the -4 to 3, because from here, that's an x value of -4, and over here, that's an x value of 3. So that distance would be 4 and then 3 more, so that has a length of 7. Well, now I've got two sides of my right triangle, so I can use that a squared plus b squared equals c squared. My a and b are 6 and 7. Those are the two legs of my right triangle. So I'm going to do 6 squared plus 7 squared equals, I'm trying to find that distance, which we call d, so I'm going to call this now d squared, which is our distance, right? Okay, so then 6 squared is 36, 7 squared is 49, and then if I add those together, that's 85. And then if I just want the distance, I don't want distance squared, well, to find that, I would take the square root of each side, right? Technically, we'd have to put a plus or minus there, but if I'm talking about distance, then I only care about the positive version, right? I can't find distance with a negative number. So really here, I only care about the positive one. So we'd get radical 85 equals our distance. So the distance between those 2 points would equal the square root of 85. 85, if I break that down, that's 5 and 17. So it doesn't break down to where I can simplify it. So I can just say the distance between those 2 points is the square root of 85. Ta-da, right? Now, we can actually take this process and generalize it to make it work for any situation. Now, this worked pretty well for us because we could draw a graph, count that distance between the y and the x values, and it was easy to count. If I make this with decimals or fractions, that might be a little bit harder for us to draw the graph and count it. So what we're going to do now is we're going to take this same process, but we're going to do it just for x and y. So x1, y1, and x2, y2, and see what happens with this, right? So let's again kind of think about that same picture. So I'm going to draw a graph here. Oh, it's a little wobbly. Okay, so there we go. And here. And I'm just going to kind of make 2 points on my graph. So I'll put one here and I'll put one down here just to kind of space them out. I'm going to call this one x1 and y1. And I'll call this one down here x2 and y2. Okay, there's my 2 points. Again, we're looking for the distance between those 2 points, which would be that line. So I'm going to call that line D. The length of it is D. That's the distance. And then what we did in the one before, remember, we counted how much vertical change there was and how much horizontal change there was. It's kind of like the slope of that line, right, is what we're looking for. So if I kind of draw in those dotted lines again, here's my vertical change. And then here is my horizontal change. And there's a right angle right there. That makes our right triangle. So, like I said, this is kind of like slope, right? When I find the slope of a line, I look at the rise over the run, or the change in the y values and the change in the x values. And to get that change in the y values, if you think about how you calculate slope, we have that formula where we do y minus y over x minus x. That's what we're doing here. So to find this distance over here, that change in the y value, I'm going to subtract those. So I'm going to take this first y value, y1, and I'm going to subtract my other y value, y2, and that would give me the distance between those 2 y values, right? Same thing for my x's. Down here on the horizontal, I can take my x1 and subtract my x2 to get that difference in those x values to find the length of that segment. That works up here, right? If I look at this one, if I take the y value of 4 here and I subtract my y value of -2, 4 minus -2 equals 6, right? Same thing with the x's. -4 minus 3 would give us -7. But here's something to think about. We don't want to have negative distance, right? So actually, when we're talking about doing this subtraction to find the length of those segments, I don't want my answers to be negative because we're talking about a length of a segment or the length of the side of a triangle. So to make my answers always be positive, I'm actually also going to put that in absolute value signs. That would always make sure that those lengths are positive, right? Okay, so now once we labeled our triangle like we did up here, the next thing we did was we plugged that into our Pythagorean theorem. So we had our a squared plus b squared equals c squared, right? Now a and b, this is like our a, and this is our b, right? Those are our 2 legs of our right triangle. And then the distance we're actually trying to find is our c. Okay, so I'm going to plug these in. So I'm going to do the absolute value of y1 minus y2 squared plus the absolute value of x1 minus x2 squared would equal our distance squared. Now, if I'm taking an absolute value something, but then I'm also squaring it, absolute value and squaring kind of accomplish the same thing, because when I square a number, it's always going to end up positive. A positive times a positive makes a positive. A negative times a negative makes a positive. So if I think about that, I don't really need the absolute value signs anymore because we're squaring it. So I'm going to rewrite this with just regular parentheses, y1 minus y2 squared plus x1 minus x2 squared. And that still equals our distance squared, right? Okay, so then the last thing is, when I'm solving this, I want to end up with just d. I don't want d squared, so I'm going to take the square root of both sides, right? So over here, now I want that y1 minus y2 squared plus x1 minus x2 squared, but I'm going to take the square root of that whole thing, and that would equal, if I take the square root of d squared, that's just d. Now again, technically we should put a plus or minus out here in front, but if we're talking about distance, we don't ever want the negative square root because distance, we don't measure negative. It's always a positive value. So I don't need the plus or minus there. All right, now that, what we have left over, I'm going to write it the other direction because this is how we normally see it. We've got that the distance, distance equals the square root of y1 minus y2 squared plus x1 minus x2 squared. Right? That right there is the distance formula. Okay. So basically all I was doing here on this first page is just showing you where the distance formula comes from. It comes from the Pythagorean theorem. It's something that you guys know very well and you probably use. You'll use it a whole bunch again in geometry next year. But using that Pythagorean theorem, that's how we come up with this distance formula. Now, if none of this first page, or if it didn't make complete sense to you, I can, again, answer questions the next time we're in class, but if it didn't make sense to you, what's important is this formula. You need to have this guy totally memorized. Once you practice and use it several times, you'll get pretty good at it. What I tend to help myself remember is I know, and most of you I think, with the Pythagorean theorem, it's a squared plus b squared equals c squared. So that helps me remember that in the distance formula, this sign here in the middle is a plus. So if that helps you. You might also remember that this y1, y2, and x1, x2, that comes from the slope formula. And slope formula, there are minus signs in there. So that can help you remember what those signs are. A couple little tricks to help you remember the formula. Okay? Okay, so now let's actually use this formula to find the distance between 2 points. So now we'll do an example where we're actually finding the distance. If I want to find the distance between, this P1 just means like the first point, and P2 means the second point. So those are our 2 points. If you'd like to graph them just to kind of get a sense of where they are, that's totally fine. But now we can just plug them into our distance formula. If it helps you to label your points so you don't make silly mistakes, go for it. I can label this one x1, and this is y1, x2, and y2. Okay. And also be aware that I know in the formula I wrote y1 minus y2 and x1 minus x2. You can also write y2 minus y1 and x2 minus x1. Just have to make sure you're consistent about either the ones are first or the twos are first for both of them. Okay. Okay, so to find our distance, I do the distance equals the square root of y1 is -1 minus y2 is 3 squared plus x1, which is -2, minus x2, which is -4 squared. And again, there's your a squared plus b squared. That's how you can kind of remember that, right? Oops, I missed a parenthesis. There we go. Okay, so then we can kind of do our subtraction inside the parentheses. Square root is going to be the last step you do here. -1 minus 3, that would give us a -4 squared, plus -2 minus -4, well, minus a negative turns into a plus, so that's -2 plus 4, so that gives us just 2 squared. And then that would equal -4 times -4 is 16, plus 2 squared is 4. So then we end up with radical 20. So our distance between those 2 points is radical 20. I want to simplify this if I can. I can pull out a 4 and a 5. That 4 is a perfect square with 2 and 2. So then that means that our distance would be equal to 2 radical 5. Where the distance between those 2 points is 2 times the square root of 5. Okay, that's how we use our distance formula. Hopefully that's a bit of review for you, or if nothing else, with that first part, it kind of gave you some background on where that formula comes from. Hopefully that makes it make more sense. Okay, the other thing we want to look at is how to find a point that is halfway between 2 points, right? So kind of thinking about the same basic setup here, I'm going to start with a graph. Now these are all positive points. So I'm just going to use this half or this quarter of my graph, right, that quadrant. And I'll plot my 2 points at, 2, 3. So that's about here, right? That's at 2, 3. And then my other point is at 6 and up at 7. So somewhere up here. And that point's at 6, 7. Okay, so now I want to find a point that is halfway between the 2 points, right? So I'm looking for, if I connect these 2 points with a line, I'm looking for this point that is right in the middle of those 2, right? And we normally call that the midpoint of that segment because it's right in the middle. So now if I'm looking again for that midpoint, here's kind of another way to think about it. I can again draw in that right triangle and think about the x values and the y values, right? So remember your horizontal down here, that's our x values. And here the x value is 2, and over here on the right side, the x value is 6. Now, the x value of the midpoint is right in the middle of 2 and 6. And then I can think about the same thing with our y values, right? The y value over here is 3, and the y value up here is 7. The y value of the midpoint is right in the middle of 7 and 3. Okay, so if I'm looking for that midpoint, we can think through it this way. We can say, well, the x midpoint value would be halfway between, we said, 2 and 6. Well, oops, I wrote the wrong number. 2 and 6. Well, in the middle of 2 and 6 is 4, right? 2, 3, 4, 5, 6. And then the y midpoint would be halfway between the 2 y values, which were 3 and 7. Well, in the middle of 3 and 7, that would be 5, right? So then that means that the midpoint between our 2 points that we graphed there would be at 4 for the x value and 5 for the y value. So this point here is at 4, 5, which is probably about right? Halfway between our x values, halfway between our y values. Okay, so now thinking about that more generally, we did an example with some numbers. Now let's kind of think about that same problem with just x's and y's, right? So again, we're thinking of, if I make this graph, we'll kind of make it the same way we did before. If I pick 2 points on my graph, right, call this one x1, y1, and x2, y2, right? And if I'm looking for that point that is right in the middle of that segment, then we said, well, we need to find the halfway point for the x's, which would be there. And then we got to find the halfway point for the y's, which would be here, right? Now, if you think about this, anytime you have 2 numbers and you want to know what's right in the middle of those 2 numbers, or if you have a data set and you want to know what value is in the middle of the data set, that's an average, right? So to find the x midpoint, or the midpoint for the x part, we want to know what's the average x value between our two, right? If I want to find the y midpoint, then I want to know what's the average y value. Well, to find an average, we add up all the numbers and then we divide by the number of numbers, right? Okay, well, to get our x midpoint, then I'm going to take my two x values, x1, I'm going to add it to x2, and then I got to divide by how many x values there are, which is 2. To find my y midpoint, I'm going to take the y values and add them together, and then divide all that by 2. And there is our formula to find the midpoint of 2 points. So this is our midpoint formula. And I always remember the midpoint formula by remembering that to find a number in the middle of something, you're finding an average. So to find our x and y midpoint, we're finding the average of those values. Okay, so now again, let's use that formula to try an actual example. So if I want to find the midpoint of the line segment joining A, which is at 4, -6, and B, which is at -3, 2, well, to find our midpoint, we're going to do the x values. And again, if you want to label these x1, y1, x2, y2. So to get our x coordinate, I'm going to take the two x values and add them together. So 4 plus -3, and then I want to divide those by 2, comma, to get the y values, I'm going to do -6 plus 2 and divide those by 2. And this, remember, this is a point that we're finding. It's the midpoint. So if it's a point, it's an ordered pair. We're finding an x value and a y value of an ordered pair, right? So then I can add on the top 4 plus -3. That would be 1/2, which is just 1/2. And then the other one, -6 plus 2, that's -4/2. I'm going to simplify any fractions that I can, and then we usually, for the midpoint, you can just put an m next to the point to stand for midpoint, and then in parentheses, my x value is 1/2. My simplified y value, -4/2, is just -2. So there's our midpoint that is between those 2 points we started with. Okay, that's how we use our midpoint formula. All right, this last one, just to practice, we're going to do both. So you've got 2 points here. G is at -11.3, and M is at 3.8. I want you to pause here and try these on your own. Find both the distance and the midpoint using your two formulas. And then I'll have you type in your answers and then come back and watch the rest, check your answer. Okay, so let's see how you did. If I'm going to find the distance between these 2 points, I'm going to do a big square root. If you need to label your points, you can. x1, y1, x2, y2. I'm going to do -11 minus 3 squared plus 3 minus 8 squared. And that gives me -14 squared plus -5 squared. And then that would give me 196 plus 25, which if I add those together, I get, oh, can I do that math in my head? That's 121. Nope, that's not right. Come on, Miss Mac. That's 221, right? 221. I can try to simplify that radical. I don't think that one will reduce any, but let me double check here. I should have had my calculator ready. There we go. 120. Oops, no, 221. I'm trying to do 121 again. 221. We can divide by 3. No, we can't. Just kidding. I think that one is... I don't know if we can simplify. 13. So that we can do 13 and 17. There's no pairs there, those are prime. So our final distance between those 2 points would just be the square root of 221. Ta-da! Okay, to find the midpoint between those 2 points, I would do the average of the x values, so negative 11 plus 3 divided by 2. And then the y values, 3 plus 8 divided by 2. Okay, so that would give me negative 8 over 2. And then 11 over 2. And if I simplify that, that puts our midpoint at negative 4 11/2. Okay, hopefully you did those okay. If you made a mistake, maybe it was just a simple sign error or an arithmetic error or something, but check yours. If you did something wrong, make sure you go back and fix it. If you can't figure out what your mistake is or you don't understand, then make sure you ask in the next class and we'll go over it. All right, you should be fully equipped now to go on to homework number 1 and try those problems. It's pretty much the same thing we did here. You're finding the midpoint and the distance between the problems, or between the points, sorry. Notice there's a couple, number 7 is a bonus problem. I think you're totally able to do that, but if you need to skip the harder ones, that one's okay to skip. Same thing with number 9. That one's a little bit harder. If you want to skip it, you can. Feel free to try it. Those are good potential bonus problems. Number 11 is a little bit different, but I give you kind of a hint there. Try it, and if you get stuck, let me know, and we'll go over it. And then there's some review here at the end of section 2. Put the equation of the parabola into vertex form, solve by completing the square, solve by quadratic formula, just one of each of those to practice. Answers are on the last page. All right, and I will see you in our next class, and we'll go over questions if we need to.